Welcome back to my classroom. This is Justine. Today we will discuss last two parts, my favorite section, that is case studies. So every net exam there used to be two case studies. One is related to the research part, another one is related to the skill construction. So let us see the first case study, which is related to the research methodology. A researcher wanted to study the effect of organization of material, that is an independent variable. They called as A on recall. So recall is a dependent variable. She expected that retention interval, that's another independent variable, would moderate the effect of organization of material. So that means organization of material is an independent variable, recall is a dependent variable, and retention level, moderating variable. So three variables are clear. We varied A, that is independent variable, at three levels. So independent variable has three levels: low organization, moderate organization, and high organization. She varied B at two levels: short retention interval and long retention interval. That means variable A has three levels, variable B has two levels. The subjects were randomly assigned to different groups. Okay, each subject received list of words with a specified level of organization. Each of them learned a list up to one errorless trial and was tested after specified retention interval. All subjects had received intelligence test. So number of items recalled by the subject was a dependent variable. We know recall is a dependent variable. The data were analyzed using ANOVA, appropriate ANOVA, that's a term, okay? Treating intelligence as a covariate. See that? Intelligence is a covariate. That's an extraneous variable. Okay, the partial results are given here. One result is sum of squares of organization of material, that is independent variable, was 255, and the degree of freedom for error variance is 115. F ratio for interaction is interaction of independent variable and moderated variable was 0.95. So the obtained results were appropriately interpreted. Very good. So now we know what is a research condition. Now try to imagine that you are doing this research. So think about the context here. So you have an independent variable A here and another variable B here, and consider this B as a moderator variable, or let us say just an independent variable. We'll see what is moderator, what is independent, like that. Okay. Now in this context, level A has three conditions. One is low organization, moderate organization, and high organization. In the retention level, you have a short period, you have a long period of retention. Okay. So you have a group like this. So this is a condition, okay, and intelligence is also measured. Intelligence is also measured. So this is a basic, it looks like a two-way ANOVA, and you are controlling this intelligence as a variable. Very simple. So randomly people are assigned to this group, this group, this group, this group, and this group, and this group. So she wants to know whether this has an effect on recall. What is recall here? How many words the person can remember? That's a dependent variable. Very simple condition. Okay, so intelligence is measured. So they were using a term there like appropriate ANOVA. This is a simple two-way ANOVA. Independent variable 1, independent variable 2, and in this context, when you control an extraneous variable, there are the methods are covariate analysis. So one is ANCOVA, or we can use a MANCOVA. These two are covariate analysis. Now what if you are trying to do this with a within group design? This all can be done when RM ANOVA, repeated measures of ANOVA. This also can be used if you are using a within group design. What if you are using a correlation design where this is an experiment, clear-cut experiment. So then you can use a method called as partial correlation to a control extraneous variable. partial correlation. So remember that if you want to control extraneous variable, the best way is to control extraneous variable in the design itself. Something like blocking, randomization, matching, like that, elimination. These kind of methods can be used. Or if you cannot control the variable in the design, then you can use these statistical methods to control extraneous variable. Now we can see each question specifically to understand what they are really looking into. Okay, so first question from the case study. So the question is, the mean square of organization of material would be. To answer this question, we need to have a very clear-cut understanding of a summary of ANOVA table for a two-way ANOVA. In this context, ANCOVA. So we'll start with the two-way ANOVA and leave a space for ANCOVA procedure also. So let us see what would be the structure of a summary of ANOVA table. So usual structure is you will be calculating sum of squares. That's what you are calculating using all the long equations. Then you will have a degree of freedom. Then you will go for mean sum of squares. Then you will have a F value ANOVA. This is how you generally calculate F2 ANOVA procedure or F value in the context. Now, what are the sources of variance? The possibilities for sources of variance are: one is between the independent variable A, 3 levels of independent variable. Then another one is between independent variable B, that's a moderate variable in this context. And you have another possibility like interaction of A and B, another one. Okay, and then you have an error. That is kind of within, and you have a total. So these are the variances that you are looking at, total variances. So the data given to us is between group sum of squares for A, independent variable A, is 255, and they are asking what is the score, MSS, mean sum of squares. So how do you calculate this SS divided by degree of freedom? That's a score that you are looking at. So what is the degree of freedom here? So degree of freedom of every variable, every source of variance is basically it's -1, like that. So let us look into this one. How many groups are formed based on A? Low organization, middle organization, moderate organization, and the high organization. So it is 3. So 3 groups and freedom of 1 is taken out. This is a concept of degree of freedom. So I will take a separate class on what is degree of freedom and what is the general principle of degree of freedom that can be done. So this is 2. This is a degree of freedom here. So now what would the mean sum of squares? 255 divided by 2. Okay, that must be 127.5. So we have an answer here. Look at the option now. Yeah, we have an option 2, 125.5. Look at the next question asked from the section. How many subjects have been employed in the study? Very interesting thing. The information given to us is based on degree of freedom of error variance. So that is the element. So to answer this question, you need to know what is the concept of degree of freedom in this level. Even if you do not know the concept of degree of freedom, the equation of degree of freedom is fine. So the basic principle of degree of freedom is n-1. So how many numbers are there, and the freedom of one element is taken out so that other numbers have the freedom to move. That's the entire idea of degree of freedom. So degree of freedom is nothing but sample size, independent sample. That's our entire concept all about. Now look at the context here. What would be the degree of freedom of error variance? So error variance is basically a kind of within group variance when you talk about between group design. So let us see. Imagine about a between group design where you have one independent variable, it's a one-way ANOVA, and 3 groups. So you have group A and group B and group C. So within each group, how much degree of freedom would be there, like that. So you have 10 members in each group. Okay, so what's the degree of freedom of within A? So it's 10-1. What's the degree of freedom within B? 10-1. And what is the degree of freedom of C minus 1 and inside the group C? So 10-1. So what is happening here? In each group, freedom of one element is taken out when you consider within group variance. Okay, that's error variance in this context. So it's basically 10 plus 10 plus 10 plus minus 3. So what is this 10 plus 10 plus 10? That is basically n, total sample, minus 3. So what is this 3 indicates? 3 is basically number of groups like A, B, C, 3. So I'm just using a symbol K. So basically, if for an error variance, degree of freedom is n minus k. So how many groups are there? So in this context, how many groups we have? We already told about that. We have 6 groups in this context. So 3 categories are based on the level of organization, low, moderate and high, and all these groups are divided into another combination, that is low retention and high retention. So 6 combinations are there. Now, so error variance of 2 ANOVA should be n minus k, and this score is 115, the score that is given to us. Now, there's a small twist in this context. We are using ANCOVA. So in the process of ANCOVA, degree of freedom of error variance will be subtracted a little bit with one value here. See that? Okay, now, so this 155 is after subtracting this 1. Okay, so that means if you want to calculate the number is 155 plus the number of groups, that is 6, and plus 1, so it's 122. This must be the answer. So this is applicable when you do ANCOVA procedure. Otherwise, you do not have a one subtracting along with that. This is a way in which they reduce the power, the amount of sum of squares. Okay, so 122 must be the answer. Let us look into the options here. Yeah, we have 122. Let us go to the next question. What would be the degree of freedom of a covariate? Degree of freedom of a covariate is a direct question. It's always been 1. So if you have 2 covariate, each covariate will have one degree of freedom. So always it must be 1. So very much direct question. So no need to think much about it. So that 1 degree of freedom will be subtracted in the error degree of freedom. So if you have 2 extraneous variables like intelligence and creativity, something like that. So when you control these 2 variables, 2 will be subtracted the same way we said. Instead of n minus k, minus 2 will be taken here if you have 2 extraneous variable. Okay, so in this context, 1 is subtracted because intelligence was our one single independent variable was extraneous variable was there. Okay, let's look into the next question. From the above results, it can be concluded that, so what is the possible result that we have? Main effect of organization of material is significant. Main effect of organization of material is non-significant. Retention interval does not moderate the effect of organization of material. Retention interval moderate the effect of organization of material. For that, look into the case study now. What are the values available to us as output? Sum of squares of the independent variable is available to us 255, and degree of freedom also we know, MSS also we know. Okay, so can you calculate F value based on that? We may not be able to do that because to calculate the F value here, you need to have this mean sum of squares, that is mean sum of squares of the between A divided by the error variance. This sum of squares is required. Okay, so let us say mean sum of squares of error is required. So to calculate this value, we need this value, which is not available to us. So the first 2 options about the significance, accepting or rejecting the hypothesis related to the effect of organization of material, that you cannot do that one. So let us look into the other data which is available to us. That is a result of interaction effect. Interaction effect, they are directly saying that the interaction effect of the F value is almost 0.95. Okay. Now the question is whether this 9.5 significance, we don't need a table for this, right? So 9.5 is obviously not a significant value. For an ANOVA, it has to be more than 2.57 something, I guess, or nearby 3. Keep a value 3 here. In t value, it must be 1.96 like that. To get a 0.05 level significance, the value must be at least nearby 3. So this is a complete rejection. So what is the interaction effect here indicates? Interaction effect indicate that the effect of A, one independent variable, that is A, its effect on B, B could be, instead of B I am using the dependent variable dV, is same in two levels of B. This is called as interaction. Look into the explanation once again. Effect of one variable, that is A, that is 3 levels. We have 3 levels here. Level 1 low organization, moderate organization, and high organization. So whether recall is influenced by these 3 levels, okay, 3 levels, is it same for a low retention group and high retention group? So this is called as interaction. It could be also possible that a condition where A has a organization has an impact on recall. Yeah, well organized, you can remember well, but irrespective of the retention interval, that means let it be short term or long term, the effect of the independent variable on the dependent variable can be significant. That means moderation effect is not significant, but independent variable one, that is if the organization of the material, that is significant, that's possible. So this interaction effect is actually indicating moderation effect. When you have a categorical data as a moderator variable and independent variable, both are categorical, right? Here 3 levels, 2 levels. In this condition, a two-way ANOVA will be perfect. So what if you have this as a continuous variable and this as a continuous or a categorical variable, and your dependent variable is also continuous? You can go for a moderation analysis using regression. Okay, so in this context, as both both variables, independent variable and moderator variable, both variables are categorical, a two-way ANOVA will be perfect. Okay, so in this context, you have to look into the condition where moderation effect is not significant. So which is the option which is talking about that possibility? Yeah, look at the third one. Retention interval does not moderate the effect of organization of material. Yeah, that's it. Yeah, now the last question in this section. The design in the above study can be best labeled as randomized single factor 6 group design with a covariate. It is not a single factor. We have 2 factors here. One is a moderator, but it is a factor here. So that is not right. Now next one, randomized balance 3/2 factorial design with the covariate. 3/2 factorial design is fine. So look into the second option little more detail. A 3/2 design is fine. What is this 3/2 indicates? So 3/2 indicates, if you say a design like that indicates it has 2 IVs. That is, this is one IV and another one is a second IV. So 2 independent variables are there and a dependent variable is being measured. So first IV has 3 levels and another IV has 2 levels. That's it. It can be 3/2 or 2/3. Any way we can write about this possibility. Okay, so this part is right. 3/2 factorial design. Very much clear. 2 factors are there. So it's a factorial design. It's a between group factorial design. So both variables are between. So it's a between group factorial design. Now what else? It's a balanced or it's unbalanced. So what's the balanced part? So you have a combination here based on A 3 groups, based on B 2 groups, so 6 groups. What if the sample size in each all combination is same? That is a balanced group. Okay, now sample size is 1 parameter. There can be multiple parameters. So let us look into the sample size itself. So what's the sample size here? 122. This is the sample size we have. Okay, so that's what we found out using the previous question. So this question is asked from the previous question, how complicated it is. So is it possible to divide this 122 sample to equally to all groups? Definitely not. If you take it to 6 combinations here, must be somewhere nearby 20 point something it will come, like definitely it cannot be an equal number in all groups. So this is not a balanced design, it's an unbalanced design. So balance option is not applicable, unbalanced must be applicable in this context. And the last option, if you look into that, is basically about the whether it's a blocked design. In the description it is just saying randomly assigned. So what's a block design? The block designs group people will be blocked into different categories based on some of their in terms of some of the uniformity in the groups, like that in this group is matched to this group, and this is matched to this group, and this is matched to this group. Based on the characteristics, they will be collected together, homogeneity, something like that, and the groups will be assigned with some kind of task. So this is simple random procedure. So you have a sample and randomly assigned to all the characteristics without looking into the characters of the subject itself. There's no blocking here, it's a direct randomly assigning the subjects. So in this context, last option is also not appropriate. So look into the option that is appropriate for us. That one is the third option, randomized, unbalanced, 3/2 factorial design with a covariate. Perfect. So that will be the right answer. Now look into the next case study, which is related to scale construction. So let us look at the case study now. A psychologist wanted to develop a achievement test in chemistry for SSC students of central schools. For this purpose, he wrote 110 items having multiple choice format. He administered this draft version to sample of 300 subjects. Okay. Item analysis was carried out by computing item remainder correlation. So what is this item remainder correlation? That has to be explained. And the item analysis retained 80 items. So some items were rejected. From 110 item to it became reduced to 80 items. The 80 item version was administered to a fresh sample of 400. So this is the next sample, which yielded a mean of 40 and standard deviation of 8. Okay, good. The score were found to be normally distributed. Oh, they are using the property of normal distribution now. The Cronbach alpha, that's a measure of internal consistency, reliability, for 80 item version was found to be 0.94. Very good reliability. Above 0.7 is considered as a good reliability. The psychologist also computed odd even reliability and Kudder-Richardson reliability for this version. So remember one aspect, this Cronbach alpha and Kudder-Richardson reliability must be almost same. It's the extension of Kudder-Richardson reliability, KR 20, 21, 23, like that equations are there. So both are Kudder-Richardson's methods and both follow same pattern itself. So these two could be same. Okay, now continuing with that. On this version, one of the subject Manas scored 32. This is related to the area under normal curve. He got a score of 32. Since 80 item version was considered long for administration, two forms from this form A and form B were prepared by randomly assigning 40 items to each form. So now we got a kind of idea. Now look into the first question. Expected Cronbach alpha for form A would be. This is a direct application and a little common sense kind of question. So look at the options there. You have the exactly same value as 0.94 itself, one option, and the next value which is nearby 0.95, that is 0.87 something. Now other values are 0.6 something, and you have another question like 0.4 something. Okay, now look at the values here. This is same one. So is it possible to have a same value? So Cronbach alpha has a very direct kind of information that this is related to number of items. So when number of items are more, homogeneity of the items are more, in this context the reliability tend to be higher. Inflated reliability tend to generally they used to get, even if some items are not really coming to the picture. If number of items are more and majority of the items are homogeneous, the reliability tend to high. This is one of the criticism for the Cronbach alpha. Now that means when 80 item version reduced to 40 item version, definitely reliability also will reduce. Now till where it will reduce? So let us say you have a score of 60 here, 60 something here. Now form A, and if you combine form A and form B, you should get the same 0.94. So for that you need to have a bigger value, so that you will get 0.9 something like that. So this option and this option may not be the possible things. Now we know that score will reduce little bit, and something which is comparable also has to be there. So in this context, this must be the answer, 0.87. This is the only possible thing. Okay, it is also possible to get a value like that, but we have a very clear-cut assumption that when number of items increases, Cronbach alpha inflates, and when the scores number of items decreases, Cronbach alpha scores also reduce. So in that possibility, this can be the best possible answer in this context. Okay, now look at the next question. So the question is talking about 95% confidence interval. So why do you need to talk about a confidence interval here? So the person has a score of 32, okay, and there could be some amount of error. The score may be because the person was in a very good mood, or the person was had a bad day that day, cold something, so his performance may not be that much good. So small changes can be there. So there can be a range of scores if the person take different same test in different days, like that. Okay, now that amount, so if a person do the test 100 times, okay, 95% of the time the score may range from a value here and a value here, and 32 will be the score like this. So if the score is very nearby, something like 30 to 34, that means this 32 is a reliable score. What if this 95% confidence interval range from 20 to 58, something like that? Sorry, if 20 to 58, like that means the value 32 is not a very reliable score. So how do we end up with this thing? It's based on the reliability of the score. So these possible errors are explained in the concept of reliability. So that means when a person has when a scale has a reliability of 0.7, that means there's a possibility of error in 0.3 of 0.3. Okay, so this 30% of error can be there. That's what it tells us when you talk about 7 as a reliability. Now, in this context, how do we come to this point? So for this, we need to know what's a standard measurement error, standard error of measurement. So this can be calculated based on an equation like reliability, 1 subtract from this, and root of this value, and standard deviation of the entire scale. We have all these values here. So we have a standard deviation 8 and root of 1 minus 0.46. 0.94. So the score is 8 multiplied by 0.06. So this is our standard error of measurement. Okay, standard error. Okay, now what's the confidence interval? So confidence interval is basically confidence interval in this context is the mean value, that is 32, and here plus or minus. Now we have to look at the interval parameter, that is 95%. So that 95% confidence interval. That means we have to use a value 1.96. What if it's 99? 99 means in the curve, based on the curve, the value will be something like 2.58 value can be taken. Now you look into the 95%, so 1.96 is the value. So 1.96 and into this value also will be nearby 1.96. This must be 32 plus or minus 3.8, some scores like this. So let us look into the option that the fourth option, 32 plus or minus 3.84, that must be the right answer. Now look into the next question. In the above study, the psychologist computed 3 reliability coefficients: Cronbach alpha, split-off reliability, and Cooder-Richardson reliability. Okay, fine. Now remember that Cronbach alpha and Cooder-Richardson reliability are the same procedure. So options A, B, C would be the same, not necessary. A, C can be same, but split off could be definitely different. 2, A and C would be same and B can be different. Oh, this is what I said now. So this must be right answer. B and C would be same, but A would be different. No chance for that. A, B, C, all 3 would be different, not necessarily like that. So option C would be right, because Cronbach alpha and Cooder-Richardson is basically calculated based on similar equation. In one condition, and they have not mentioned Cooder-Richardson which equation. Cronbach alpha is also a Cooder-Richardson equation. So in that context, square 20 is an equation that we use generally for dichotomous response pattern, yes or no, correct or wrong, like that. Option 2 would be correct. A and C would be same and B can be different, like that. Okay, now look into the next question. For computing item reminder correlation, which one of the following correlations would be suitable? Now try to imagine about a possible data structure. So you have 80 items here. So something like item 1 and 2 and 3, like that. You will have 80 items and you will add one person score, you will get a total score here, total, and this must be the total. So what's an item remainder correlation? You must be familiar with the item total correlation. So we'll take one item and the correlation value, like this item total correlation. And what is the item remainder correlation? So what happens is, when you find out item and total correlation, there's always a chance for inflated correlation, because item's contribution is also in the total score. Item is also added when you calculate the total score. So definitely variance of this one is also shared in the total score. So some researchers say that this method is not appropriate to understand whether item is following same pattern as total. So instead they argued for they forward a new idea where you may eliminate this item and add all other 79 items, okay, and you'll get a total score for 79 items. Now you will calculate item 1 and this total score, where this 79 items are used where this item is not included in that one. So that means separately we are trying to check whether this item is related to all other remainder items. So this remainder items. So this is called as item remainder correlation. Now the question is, which statistical method has to be used? Now remember, what kind of responses people get when they answer. So this is a chemistry exam, not a Likert scale. So one answer has to be the right and other answers definitely wrong. So the responses are right and wrong. So you'll get pass 1 mark. That means yes, a correct answer, wrong answer 0, 0, 0, 1, 1, like that. This is a possible thing. Now look at the total score. What would be the total score you like? You will get addition of different items. You may get score like 23, 24, 27, like the different scores you will get. Now you are expected to correlate this item with this total score. So one is a continuous variable, this one is a categorical variable, that too dichotomous category. Dichotomous category means two options are there, zeros and ones, like that. So these are the options that we have now. So one variable is categorical, that is dichotomous categorical, other variable is continuous. So the direct option is biserial correlation, biserial correlation. Now the another question, which biserial correlation? Whether this dichotomy is a true dichotomy or a artificial dichotomy. So what's a true dichotomy? So true dichotomy means these options are very genuine in nature. For example, a person, male and female, it's a very genuine kind of dichotomy. Whether the person has come or not come, joined for a program, not joined for a program, it's a genuine dichotomy. So what could be an artificial dichotomy? Let us say I conducted an exam and I say that about 30 people will pass. So the 30 is a value that I have put forward. Then I have decided above 30 it's 1, that is pass, below 30 it's fail, 0. So dichotomy, it's also a dichotomy where the dichotomy is an artificial dichotomy, not a true dichotomy. So in this context, one answer is right, which is not something that I put forward. It's actually one is correct and other things are wrong. So in that case, this must be a true dichotomy. So the correct answer would be point biserial correlation. Otherwise, it's simple biserial correlation if the dichotomy is not true dichotomy. So let us look for an answer like point biserial correlation. Here the third one, point biserial correlation, fine. That's the correct answer here. Go to the next one. The score of 32. That's a person, Manas, he got it. Would correspond to percentile rank. Now we need to think about the normal curve property here. Yeah, so let us see. So always remember that when you have a data where normal curve properties are mentioned, they will be referring to area under normal curve. Most probably they will be doing that one. So let us draw the situation here. So according to the data, when they used 80 item scale, so they had 40 as a mean and 8 as a standard deviation. Okay. This is a condition. Now they are asking for a percentile. So percentile means how many people from one side and like this. Okay, now when I take the video, I will flip the image. So I don't know whether this is starting from the 0 area itself. So this is minus for me and this is plus condition. Okay. So it may come properly, I guess so. Now they're asking a value 32. Now look into this one. This is mean plus 1 standard deviation. What is that? 1 standard deviation value. That is mean plus 148. This is my standard deviation. And mean 1 standard deviation below, this is 32. Yeah, you got the value 32 here. Now they're asking where this 32 will fall. What's the percentile position here? So now look into the entire percentile thing. These many people under the curve, you have 100%. That's right? Entire sample is under this curve, and half of them will be 50%. Yeah, right? So percentile position, if you look in the 50th position, will be the center point. So that means if assume that in this study we have 100 people, the 50th person will be falling here. He will get a score of 40, like that. Now this much area is 34. That's the area under normal curve. 34% here, 34% here, 12 point some percentage here. There is minus 2 standard deviation. Like that, it will gradually reduce. This is a property of area under normal curve. Now they are asking the percentile. So among this 50 percentile, 34 is here itself, the balance. So 50 minus 34. Let us say whether we have a value something like 16 or something. If it is right, that's our answer. So this particular point is given exactly based on this property. So remember this part. You do not have a calculator, so they will be asking always values like this, either 1 standard deviation or 2 standard deviation as a part of questions. Otherwise, it is impossible to calculate without the algorithm table or calculators and all. So they will be following some pattern like that. Anyway, let us look into the data now. Options now. Yeah, the first option itself is option 1, 16. So that's our score. So that's the end of it. We have solved 2 case studies. We took a lot of time as we are explaining a lot of elements in between. So these case studies are my favorite things when I see the net question paper. So always remember that even before the NTA take this exam pattern, we always had this case study and a few questions. So you get a hang of it, you can easily answer this question. Read that very clearly, okay? So don't worry about the complication about it. You read many times, so you will understand. Some of the questions are very direct, some of the things are little complicated. You need multiple information to synthesize together to get the correct answer. Now it's a time to wind up. Bye for today. I will be coming with the topics in the next class onwards. So last year question paper is over. So if you have any doubts related to the things that I have discussed, don't worry about it. I'll be taking each concept very detailed, like what is degree of freedom, how it is calculated, what's the theoretical understanding of it. I'll be taking videos related to that. Now I was just solving the problems, so there was some kind of vagueness must be. I got some messages, personal messages, where they were saying that they could not follow the way I answered some of the questions. That's fine. So if you have any doubts, comment below the section. I will try my best to make videos related to that one, or send you some kind of personal details so that you can get more clarity in these topics. So bye for today. See you in the next class. Bye.